Hi, this is r.swathiramya, Assistant Professor AIDS Department, and you are here with me in IOT lecture series. In this video, we are going to discuss about the physical design of IOT. This is the standard interface for the wired network connection. It allows the IoT devices to connect to local area network, that is LAN, for the reliable and high speed data communication. The port has been used for, this is very standard port, already we have been known very well about the Ethernet. So, it works accordingly. Okay. So, for connectivity we have got two ports, USB host and RJ Ethernet. USB allows us to connect and communicate with other devices with the help of USB port, and Ethernet, it is a wired network connection. This also helps us to connect the devices and also to connect the storage area. Okay, this is the thing of connectivity. So, next we are moving to the next part, that is processor. Obviously, the work of processor is very well known thing. The central processing unit, you need a central processing unit to control all the activities which is happening inside the IoT system. So, USB is a brain of IoT devices. It executes, it gives you the instruction, and it gives you the instruction in the form of programs and manage all the operations of the components, of all the components like sensors, actuators and device communication. Everything will be under the control of this processor. It processes the data and perform computation which is necessary for the certain applications, and it will give you the actions, what all the things we need to do. Accordingly, the entire operation will be working on it. So, this is the thing of processor. We know what is connectivity, what all the things we are doing in the connectivity, and we've been discussing the processor also. It is a whole entire control unit where that will give you the instruction what to do, what has to be communicated, what data has to be moved from which device to which device. All the instruction will be given by the processor. So, entire things will be handled by the processor. Next, we are moving towards audio video interface. We have three parts in audio video interface, starting from HDMI. HDMI stands for High Definition Multimedia Interface. This interface is used to transmit high definition video and audio signals from the IoT device to display devices like monitors and TVs. And there comes for the next one, 3.5 mm audio. It is a standard audio jack used for transmitting analog audio signals to headphones, speakers, other audio output devices. Third comes RCA video, an analog interface for it is also an analog interface which helps to transfer video signal commonly used in older AV equipments, that is audio video equipments. For currently we are not using RCA video or 3.5 mm audio video. Mostly we use HDMI. Okay. So, next we are moving towards input output interface. See, generally in IoT system, input will be from the sensors. Okay, I mean we collect data from the sensors from the real time environment. Sensors will be giving the input for IoT system most of the cases. We have different type of sensors depend on our application. For irrigation we use humidity sensor, for home automation we will use temperature sensor. We have different for home automation we also use the motion sensor, light sensor, different kind of sensors depend upon our application. We use different type of sensors. This will be the input. Mostly this device will give you the input. Output will be in the form of actuators. Actuators will be the output which will control the mechanical activities. See, mechanical activities will be done by actuators. For example, controlling the valve in a smart irrigation, you have to control the pipe valve. Okay, it will be done by the actuators. So, there comes input and output interfaces. So, input and output interfaces, we have the four things. We will start from the UART. UART is nothing but U stands for Universal Asynchronous Receiver transmitter. So this is a serial communication interface used for asynchronous data. From the name it's very clear, it is going to transmit and receive asynchronous data. So same as it does, asynchronous data exchange. It helps us to transfer, communicate the asynchronous data exchange between the IoT device and other components or devices. Here we transfer asynchronous data between two devices. That is what the purpose of UART, Universal Asynchronous Receiver Transmitter. Then comes SPI, which stands for Serial Peripheral Interface, a asynchronous serial communication interface used for a short distance communication, which is primarily in the embedded system. Okay, this is for synchronous data. For asynchronous you have UART. For synchronous data you will use SPI, Serial Peripheral Interface. Next comes I2C, which is nothing but inter-integrated circuit. That is I2 in the sense inter-integrated circuit. This is also used for asynchronous serial communication. Asynchronous data has been transferred from one device to another device. Here we use a same circuit board, so it is called inter-integrated circuit. Asynchronous serial communication interface used to communicate between the components on the same circuit board. When the communication has happened on the same communication board, that time we will use I2C. When it has been transferred between two devices, then we will use SPI, that is Serial Peripheral Interface. When it has happened on the same circuit board, then we will use I2C. Next comes CAN, which is nothing but Controller Area Network, a robust vehicle bus standard designed to allow the microcontroller and the devices to communicate with each other without the host computer. Here the communication is happened without the host computer. That is why it is called Controller Area Network. Here it allows the microcontroller and devices to communicate with each other without any intermediate host computer. For that case we will use this CAN. Okay. With this I will wind up my session, and for the next video I will continue. Other interfaces. Thank you. Bye bye.